Okay, let's talk about how we find the total surface area of three-dimensional shapes. We're going to start with rectangular and triangular prisms because that's a nice easy spot to start with. So if we have a look here, we have a rectangular prism. You can tell because it's just made up of rectangles. Now if we were to name all of the faces, because we're looking at surface area, so all the different areas that we have, we will see that we have there's one here, but there's also that same one on the back side. We will have one here, big one on the front, but there's also the same one on the back side. And then we'll have this one on the top, but then there's also the same one on the bottom. So let's just work out one of each of the areas of these things. So for area A, it's just the length times the height. That's area A, and that's repeated over here. For area B, which is repeated on the back, it's just the width times the height. For area C, we have the top or the bottom, which is just the width times the length. Now that's fine, and we don't even need to find the other area that fits because they're exactly the same. The only thing we need to do is when we come to put it all together, we need to make sure that we have got two lots of each of these areas. And so the formula for finding the surface area, the total surface area of a rectangular prism, will be 2 outside of, and then the area of each of those faces. Okay, so that's triangular prisms. Oh, well, I kind of stuffed up here. If I really wanted to be correct, I would need to have the word surface, the total surface area. All right, fix that problem. Let's talk about triangular prisms. Now, triangular prisms are no different. We have a bunch of different faces. We have, here's a front face here, but then we also have the back face there. And then we've got the left face over here, and we've got the right face here, and then we've got a bottom face underneath the bottom. We just got to make sure that we account for every single one of these faces as we are finding their areas. So let's have a look at each of these areas. Well, the first one is the area of the front, which is exactly the same as the area of the back. And we know that because it's a triangle, that the formula will be the base times the perpendicular height divided by 2, which, as you can see the maths there, gives us 7 centimeters squared. Now don't forget though, in your head we know we've got 2 of those faces. We're going to have to account for that. We then start looking at the left, the right and the bottom sides. We have areas, then they're all the same because this is an equilateral triangle. Each of those lengths is 4 centimeters. So I can say that they all equal each other. The area of the left is equal to the area of the right, which is equal to the area of the bottom. And you can even write it like that and then show your formula. The formula here will be just length times width for each of them. Each of them all have the same measurements, and you can see the maths there that they all end up measuring 72 centimeters squared. So when we come to put this whole thing together, we need to remember that we have 2 of these areas and we have 3 of these areas. So you'll see that as I write my total surface area, I have accounted for the 2 of the area of the front and the back, and the 3 lots of the areas of the sides, the left, the right, and the bottom. Okay, so you just add them all together once you've done that multiplication for each, the number of the faces, and that is how you find the surface area, the total surface area of triangular prisms.